So today we're gonna start a new chapter, but that is closely related to linear functions again. Okay, so we're gonna do everything that we've done so far. We're gonna be using all the tools that we have at our disposal. But we're just gonna do something a little bit more challenging over here. So essentially, we're going to be working with two functions at once if you want. So for the starter question, right, I'm going to ask you to actually plot these two functions that you see on the same Cartesian plane. Okay, so sketch both of them on the same Cartesian plane. Um, and then something interesting will hopefully happen. Okay, so yeah, so just do that. I'm gonna continue. You can pause the video and maybe try plotting the two functions. So yeah, one more thing. So before I guess I start, I'm just gonna thank the students who took their time to um, um, I guess do the survey. I have read your suggestions, and I'm going to be implementing those into my teaching practice. So thank you once again. By the way, if you would like to share more suggestions, you can just comment on the post that includes the video. You can make your comment private, like some students are doing, and then I will, hopefully try to include that in my videos. Um, yeah. So again, I'm gonna point out a few things that I've done this week that I initially was not doing. But yeah, thank you very much for sharing your comments. Now for the French immersion students, I know that I'm not making a video in French. Um, and I think I went over this at the beginning when we had our mandatory office hours. So even though I'm not doing the video in French, just know that I'm posting the notes for you in French. So I would just recommend printing those notes off and then following my video in English. Okay, because it's exactly the same notes. It's just it's written for you in French. So that way, you're not gonna get confused with the vocabulary and stuff like that. Okay. Unfortunately, I cannot make your test in English. Okay, because you're French immersion students. I cannot do that. Um, but I'm gonna ask you to just use the French notes. Okay. Anyway, so how do you graph this? Okay, so let's start with the function in blue, right? Again, I know that my y-intercept is -1, right? Just by looking at this. So you know what? Let's just quickly scale this. So let's just say this is 1, and this is 1. Okay, so that means this has to be -1, -2, okay, and -3 or whatever. And then this is 2, this is 3, and -1, -2, -3. You don't have to, put the numbers in, because if this is 1, this is 1, everything else will just fall into place, okay? So let's start with the blue function. So I know that my y-intercept is -1. So that means when my x value is 0, my y value is -1. Now, if I plug in x is equals to 1 in my function, right, then my y value will be 2 times 1, which is 2 minus 1, 1. Okay, so at 1, I'm 1. At when x is 1, my function is at 1. Okay, so it starts off at -1, and at 1, my function is at 1. Okay, so now that you have your 2 points, right, you can just quickly sketch this function. Okay, so this is the function in blue. Now let's graph the function in purple. So the function in purple is the y-intercept, right, is 1. So that means when my x value is 0, my y value is 1, right? Because that's the definition of y-intercept. And when x is 1, my function will be at 2, okay? And then let's just continue. So at 2, I will be at 2 plus 1, which is 3. And in this case, when x is at 2, my function will be at 2 times 2 is 4, minus 1 is 3, okay? So I'm just gonna, just circle this, okay? And I'll talk about this a little later, okay? So as you can see, both functions when the x value is 2, both functions have the same y value, okay? So anyway, so let's just graph this function in purple. I start off at 1, and then at 1 I am at 2. So maybe let me just increase this a little bit. So this is 2, and then the next one has to be 3. Okay, so I start off at 0, 1. This is my point 0, 1. And then at 1 I am at 2. So at 1 I'm over here. Okay. And then you can again just connect the two dots. Okay. And this is your special point. Okay. I'm just going to put the special point here in green. Okay, so this is a special point, right? So this is the point 2, comma 3. As you can see at this point, okay, we call this the point of intersection, okay? So which is basically the focus of today's class. Why is it the point of intersection? The point of intersection means it's a special point where both functions, the function in blue and the function in purple, have the same x value, right? Both of them. So you see the x value of this function is 2, the x value of this function is 2. So it's a special point where both functions have the same x and y coordinate. Okay, so x is 3, y is 3, y is 3 in both cases. Okay, so this is a special point where both functions have the same x and y value. Okay, so you can find the point of intersection by graphing it, okay, kind of like I did. You guys probably have a graphing paper at home, so if you graph this, it shouldn't be too difficult, right? So this is your point of intersection. Okay, so maybe let me just do this. Okay, so this is your point of intersection. Very important point again. It's the point where both functions, right? Both functions, this function in blue and this function in purple, share a common coordinate. Okay, so by that I mean both functions will have the same x value and same y value at that point. Now, if see, again, you can find the point of intersection if you graph, right? But that's tedious. Okay, that will that takes a lot of time. Okay, so how do you? The question becomes, how can you find the point of intersection algebraically without even having to graph the function? Okay, so that's what I'm going to show you. In the starter question, I'm just showing you how to find the point of intersection using the graph. Okay, now one more thing that I'm going to mention. So 2x minus 1, x plus 1. If you have a graphing calculator, okay, if you have a graphing calculator, click on the top left side where you see this. I can't really touch over here. You're not going to see it, but basically this y is equals to on the top right. Click on y is equals to, okay? And then you can put your function over here. Okay, the first function was, I believe, 2x minus 1. Okay, and the second function was x plus 1. By the way, this x comes from, you see the button on the right hand side of alpha, you see xt and then your angle theta. That's where I'm getting the x from. Okay, so if you click on that, you're gonna make x's. Okay, so let me just clear this, I guess. So x plus 1, and then you can trace this, and you will see that there's going to be a point of intersection. Okay, kind of like, and if you zoom in, right, it happens at the point 2 comma 3, just like the way I drew it. Okay, so if you have a graphing calculator, you can use that to help you with this. But when you go to 20-1, your teachers will talk more about that. Okay, so in this case, now let's move on. How do you determine the point of intersection algebraically? Okay, so without graphing your functions, because again, graphing is very time consuming. There is a method known as the comparison method. Okay, so how does that work? When you have y is equals to something, okay, and you have the same variable, y is equals to something, then you can compare the two variables because they're one and the same. Okay, this is a y, this is also y, okay? So what you can do is you can compare your two variables. How do you compare? Just, you know that, remember, the point of intersection is a special point where both your x and y values are equal, right? So you just have to equate the two variables. Y is equals to y, okay? So because, okay, so if it's kind of confusing, you think of it this way, okay? So um, let's just call this y1 and let's call this y2, okay? So all you have to do is make y1 equals to y2, because remember, both the functions will share the same y value, right? As you saw in my starter question. So make y1 equals to y2, okay? That's the first step. You're comparing, right? Um, again, the two variables that are the same, both of them are y. I'm just making it y1, y2 so that you know exactly what I'm trying to do over here. Okay, but what is y1 equals to? I'm gonna replace y1 by this, okay, because y1 is equals to 2x minus 1, so I can replace that by 2x minus 1, and y2 is actually equals to x plus 1, so I'm gonna replace this y2 by x plus 1, okay, and now um, I have an equation with one unknown, so I can easily solve for x. Okay, so let's solve for x. So when you have an equation like this, the technique that will help you solve for x is make sure you bring your variables on one side, right, and your numbers on the other side. Okay, so there's many ways of doing this. Okay, one way to do that is just understand that I have to move this x. Again, you could either move all your variables to the right and numbers to the left, or all your variables to the left and numbers to the right. Okay, it doesn't really matter. I just like to keep my variables to the left. Okay, so if I move this x over to the left side, the sign will change, okay, because this is plus x, it's positive. So 2x, this is not moving, so it still remains the same. I have to move this x, so this will become minus x, right? And then I have to move this minus 1 over to the other side. So this plus 1 doesn't change because it's not moving, so plus 1 is still just 1, right? Now I have to move this negative 1 over to the other side, and it will become, because it was minus 1, it will become plus 1, okay? So that's one way of doing it. Another way is to do the opposite, okay? So if this was minus 1, right, then you do plus 1 on both sides, so this will disappear. This is plus x, then you do minus x, and this will disappear. Okay, it doesn't matter how you do it, you're going to get the same thing. So 2 minus x, right, I can simplify that. Remember, these are like terms, right? So all you have to do is subtract your coefficients. Remember, the coefficient here is 1 if it's not visible, right? So 2 minus 1 is just 1. 1x is just x, okay? So x is equals to 2. Okay, so using algebra, I know that x is equals to 2. Now, this is what I want you to do. Once you find what x is, which is what we have in our starter question, right? So we've done half the work. I know what x is, but how do you find y, right? That's the question. How do you find y? Remember, once you have your x, okay, it doesn't matter which y you're choosing. You could plug this x into the first equation and find what y is. Okay, so let's do that. So y will equals to 2 instead of x, right? I'm gonna replace x by, so in my first equation, you know what, let me just write this down. So my first equation is 2x plus 1. Now I'm gonna replace this x over here by 2. Okay, so it's gonna give me 2 times 2 plus 1, which is equals to, sorry, 2 times 2, this should be minus, right? So let me change this to a minus. And that means this also has to be a minus. Okay, so 2 times 2 minus 1. So 4 minus 1 is 3. Okay, now what if you plug this x into this equation? Okay, what if you chose this one? It doesn't matter. Okay, if you chose that one, you're still going to get 3, because look, I'm going to replace this x by 2. So 2 plus 1 is also equals to 3. Okay, when you equate the two y values, right, that means that once you find your x, both your y values are going to be the same, okay? And you can choose whichever function you want to replace your x in. Both of them will give you the same y value, but just to be on the safer side, I'm gonna ask you to do that for both your functions, okay? Both of them. just to see if you're getting the same thing. If you're getting the same thing, that means you've done this correctly. If not, that means you made a mistake. Okay, so now I know that my x value is equals to 2 and my y value is actually equals to 3. Okay, so your point of intersection is 2 comma 3. Okay, that's how comparison works. Okay, so right, once you have the same variables y and y, you can compare them because it's the same. So just make y is equals to y. I put 1 and 2 um just to show you what I was trying to do. Okay, you don't have to put the 1 and 2, but that was just to distinguish between this top equation from the bottom equation. Okay, so the second question is a little bit more